Hello everyone, my name is Shrestha and I'm a PhD student at Boise State University. Today, I'll be presenting our work on investigating how readers identify the reliability of news when provided title, image, source bias, and full article. The problem of fake news spread has been rapidly increasing due to the proliferation and popularity of social media as a platform for information diffusion. It has been identified as being more likely to go viral than real news, spreading both faster and wider. One of the reasons for this spread is human activity, as people tend to fall for fake news and further share them on social media. So the question here is, why do we fall for false information? Because humans are generally poor at correctly identifying false information, and it has been highlighted by several studies. For instance, a study showed that humans could identify Wikipedia hoaxes with only 66% accuracy and identify fraudulent reviews with only 53 to 62% accuracy, which is as lower as random. While Wikipedia hoaxes and fake reviews are related, there is difference between them and fake news. Specifically, fake review is a dishonest individual's opinion in a context where there is no absolute ground truth. And a Wikipedia hoax is false information pretending to be true and sometimes intended as a joke. While fake news is false or misleading information that is spread deliberately to deceive reader. And when we look at news domain, people are even worse at identifying factual statements and opinion statements according to Pew Research Center. Thus, it is important to understand what are the factors the readers rely on to identify the reliability of news. Within this context, in this work, we seek to understand the accuracy of people when evaluating fake news with varying granularity of information. We selected the metadata elements such as article title, image, source bias, and excerpt in our study because news in social media can be presented in different ways, such as with only headlines or only with headlines and images or with text only, as shown in this figure. Unlike the previous study, where multiple metadata are presented together to identify fake and real news, our study begins to tease out which elements are most relevant. Also, we compared human versus computer accuracy with varying combination of news elements. To the best of our knowledge, there is no study comparing people's accuracy in judging combination of news metadata elements and excerpt. For this, we considered fake news net dataset, as other existing datasets were labeled based on the credibility of the source. Whereas this dataset contains labeled real and fake news from PolitiFact and BuzzFeed fact-check website with metadata which are required for our study. Then we extracted the article source bias from Media Bias fact-check website, which assigns 7 degrees of biases from extreme left to extreme right, which we grouped into 2 categories, right-leaning and left-leaning, to generate the data for our survey. We randomly selected 16 real and 16 fake news articles that were balanced in terms of number of left-leaning and right-leaning news, and conducted an online survey where we asked 175 participants to categorize news as real or fake and provide an explanation for their decision. So participants were provided 4 different types of questions with varying news information like title and image, or title and bias, or title, image and bias, or excerpt only, where each participant were exposed to total of 18 articles, 3 for excerpt and 5 for each remaining conditions. Then, from the responses we collected, we measured how accurately they were able to identify fake news and perform pairwise comparison for each condition, as shown in the table. Here, statistically significant comparisons are highlighted in green. From this analysis, we found that including images helped participants to identify fake news more accurately because it improved accuracy for title and image condition with score of 0.62 and the title, image and bias condition with the accuracy of 0.617, and the difference is supported by statistics as well. Thus, if we look at overall accuracy, we can say that people are not accurate at detecting fake news, as their accuracy is at most 60%. We further group participants based on self-identified political orientation to investigate how political ideology affect in identifying fake news. Very few participants self-identified themselves as extremely left or extremely right, so we collapse the political leaning into three groups: left-leaning, neutral, and right-leaning. Here, neutral is same as moderate, used by some other established scales. Then we compare the accuracy of those groups for each condition using Kruskal-Wallis test, and then pairwise comparison test for only significant condition, that is title and image. Then we observed that left-leaning participants were significantly more accurate than right-leaning participants, and other two comparison, that is left versus neutral and right versus neutral, were not statistically significant. Next, to understand the reason behind their decision, we analyzed open-ended responses that were given by participants for classifying each item as real or fake. In doing so, we used an inductive approach to generate codes where three of the authors independently coded the participants' responses and finalized them if at least 2 of 3 reviewers utilized that code, and if all the reviewers were in agreement on using that code. Altogether, we coded 320 responses from title and image condition and excerpt condition, as highest accuracy was in title and image condition and the lowest accuracy was from the text excerpt condition. The main purpose of generating this code is to identify the prominent themes that illustrated the approaches used by participants to identify whether the news item were real or fake. Looking at the top 5 most frequent codes, we observed that in the title and image condition, responses that refer to the elements of the image, like picture unprofessional or picture professional, were more often correct than incorrect in accurately labeling the news item. For example, correct responses often came with reasoning such as pictures look fake and photoshopped, whereas responses with more subjective elements, like perception about the person in the news story, were more often incorrect than correct in labeling the news item. Whereas in case of excerpt condition, the pattern was less clear, probably because of the challenge participants faced in this condition, and thus the accuracy is also lowest. However, we observed that the responses referring to the perception about the person in the news story tend to show up more in incorrect responses than in correct ones. Further, we used the same information evaluated by participants and implemented an automated machine learning-based fake news detector so that we can compare human versus machine accuracy under the same condition. We used look and readability feature from excerpt and title, and we also included image features extracted from ImageNet VGG19, face emotion using Microsoft Azure Cognitive Service API, and image quality like blurriness using OpenCV blur detection, and also the source bias as input to logistic regression classifier with tenfold cross-validation to classify fake and real news. From the comparison, we observed that automated detector outperformed humans on identifying fake news article. In particular, both human and machine learning model makes mistake in identifying fake news when looking at just excerpt, which indicates the importance of other information in identifying fake news. We can also see that including source bias does not help people in determining reliability of news if participants already have the title and image information. However, including bias in the machine learning model increased the accuracy by 2%. To conclude, our research shows that humans are less accurate in identifying fake news when they have only the text of the article compared to when they rely on metadata. In particular, humans were more accurate when they had pictures available than when only the news excerpt is available. Analysis of open-ended participant responses revealed that professionalism of image was a helpful heuristic that enabled more accurate judgment, whereas participants' prior perception of the people being reported on more frequently led them to inaccurate judgments. And overall, political ideology leaning had a little effect, though left-leaning participants were more accurate than right-leaning participants when categorizing news article as real or fake based on only headline and image. Finally, automatic detection outperformed humans on identifying fake news article by 21% accuracy, showing humans are poor at identifying fake news. Thank you.